Hi. My name is Alexander Baker, and I was I'm a data scientist, currently working as a subcontractor from Booz Allen, and I wanted to introduce you all to um, data visualization basics. So, to start off with, um, data visualization is essentially the practice of representing data through some sort of visual medium. And data you can kind of think of as a collection of information um, that can be particularly useful for drawing insights. These can these can be used to create charts, and charts are essentially the building blocks for creating a story. And these can be displayed on a dashboard. So the purpose of data visualization is humans can process text about 60,000 times faster than, or process visuals 60,000 times faster than processing text. And this allows people to quickly gain insight on various aspects of a collection of information. And this can be a very powerful support tool and the foundation for informed decision making. So before we go into data visualization, it's kind of important to go over the different types of data that you might encounter. So the first distinction that I'd like to go over is the difference between categorical and numerical. The categorical data is essentially consists of labels and names. So you can kind of think of this as a collection of student categories like subjects in classes, maybe maybe yeah, like a collection of subjects in classes, grades like A, B, C, D, and so on and so forth. Numerical is more, as the name suggests, it consists of numbers. These can be heights, weights, so on and so forth. So, splitting these into further categories, you have nominal and ordinal versions of categorical features. So, the nominal category is is considered not ordered. So these can be like students' names, subjects, uh, it's important. Again, there's no indicator that one is particularly over another in any way. Uh, Ordinal is different. These can be like like grades. Like they are labels, but they are ordered. So grades are a good example. Like A, B, C, D. Like obviously A is better than a B is better than a C, and a C is better than D, so on and so forth. Then splitting the numerical, there's interval and ratio. An interval scale of data basically has is basically data without a true zero, and ratio is data with a true zero. And what I mean by a true zero is that zero is an indicator that there's an absence of anything within that particular scale. So a zero. So for example, temperature. Fahrenheit can be on an interval scale, and ratio will be on a. Temperature will, or Fahrenheit will be on an interval scale, and and Kelvin will be on a ratio scale, since Kelvin has an absolute zero. And then discrete and continuous versions of numerical data, you can kind of think of it as counted versus measured, where a discrete is like the number of marbles in the bag, and continuous would be something measured like weight or height. So to approach data storytelling, it's important to keep in mind what you plan to accomplish when you're trying to move towards your goal, and which techniques can properly visualize certain data when you're approaching said goal. Uh, First technique I'd like to get into with you is a histogram, and a histogram is essentially um, a frequency diagram for one particular one particular numerical variable where each of the each of the values are grouped into buckets, and that is demonstrated in the bars over here. Histograms can be very useful in visualizing the distribution of a single numerical variable. However, you will have to keep in mind that outliers or dominant buckets can obfuscate your graph. Next is the bar chart. So bar charts plot a single categorical variable and are very useful for displaying the frequency of these values. So um, so it's important to consider when using a bar chart. Exorbitant categories can prevent the readability of your particular chart, and dependent categories can obfuscate other bars. Um, yeah, bar charts are very useful for displaying the frequency of particular categories within a single categorical feature. Next is the pie chart, which is pretty similar to a bar chart, but it's more useful in displaying the prevalence of particular categories within a given categorical feature. So, um, and you basically, and I'm sure you've seen pie charts in a lot of movies, especially when people are considering this is the amount of time you spend, this is the amount of time you spend doing something, this is the amount of time you spend doing something else. The same pitfalls are present for pie charts as bar charts. Overly exorbitant number of categories can make your plot unreadable, and an overly dominant categories can obfuscate other pieces of your pie chart. Next is the stacked bar chart. So, unlike the previous two, this is good for demonstrating the relationship between two categorical variables. You can see that each categorical variable, the categories of one categorical variable are split up into different bars, and those categories are further in each bar is further split on another category. So these relationships can be very easy to demonstrate to your user via these charts. So you can kind of consider this like if you're looking at the amount the animals adopted at a pound, cats and dogs will be on your x-axis, and that can be two different bars. And then those bars can be further split into adopted and not adopted, and you can see a relationship between if dogs are more adopted than cats, or if cats are more adopted than dogs, so on and so forth. So it's a really good tool to visualize the relationship between two categorical features. A scatter plot, similar to a scatter plot, is used to display the relationship of two numerical features. So you essentially have, I'm sure you've encountered this sometime, the X and Y plane. You have one feature on the X and one feature on the Y, and both of these are used to generate points on this plane. And those points are used to essentially show a relationship between these two numerical features. Now, bubble charts are a version of these scatter plots where size is also taken into account, and this can plot a third numerical feature on this plane. So not only do you have the x and y, not only do you see the dots generated by the x and y, but you see the size of each of these dots that's generated as some sort of z. You can kind of consider that as some sort of z or a third dimension. So you can see the relationship between three different numerical variables. Time charts are essentially plotting the behavior of one particular numerical feature over a select period of time, and these can be displayed in a variety of ways. The one I chose in this example is through lines. Now, when looking at a line chart or a time chart, it's important to keep in mind that if you're comparing the behavior of two different features that are on radically different scales, this can obfuscate the behavior of one other feature that you have. Finally, there's geospatial plotting, which is very useful for plotting the behavior of a particular feature with respect to latitude and longitude. So this can be very useful if you want to create maps of poverty and energy consumption over the world, or within a particular country. It can be a very powerful technique for demonstrating which area, the behavior of particular countries or counties, land masses that exhibit a certain behavior in comparison to others. Now, it's important to not overwhelm your user with too many land masses when you're doing this, and if certain land masses are particularly small or hard to read, that can be difficult for your user to observe. So, general warnings when plotting, you always have to keep your readability in mind. Make sure that you keep the number of categories, points, features on your plot to a manageable degree so that your user is able to actually understand the point you're trying to make for your graph. Another important thing are outliers. Outliers can always obfuscate a lot of information within your graphic and make the general point of your plots difficult to understand. Uh, Keep titles, legends, and text concise and always and informative. Make sure that your user can actually understand them. And now for your conclusion, you will encounter a lot of these concepts in labs, classes, offices. These are very common in basically every facet of life where information is involved. And within this topic, I use several techniques that you can use to demonstrate various types of to show various types of data. And always remember to focus on the readability and your overall narrative when creating these charts. So some next steps, I included some examples of more advanced charts that you can go over, as well as some softwares you can use to essentially create these charts very easily and quickly. And that's the talk on the data visualization basics. Thank you.